today I'm going to be covering question 4 from the assignment. So consider points A, B, and D. Find the point C such that ABCD is a parallelogram. Draw figures and carefully express your thought process. Then write a general form equation for the plane that includes A, B, and D. Then show that, as it is expected, point C lies on that plane. So we know points A, B, and D. Since ABCD is a parallelogram, opposite sides must be equal and parallel. So vector AB must equal vector DC. So here I've computed vector AB and I get 2, 2, 2. So you can isolate for point C by taking point B, subtracting by point A, and then adding point D, or vector AB plus point D. And from there, you get 1, 0, 4. So now we're going to find the equation of the plane through A, B, and D. To write a plane's equation, we need a point on the plane, so we'll use A, and a normal vector which is perpendicular to the plane. So we get the normal vector by taking the cross product of two non-parallel vectors lying on the plane, so AB and AD. So AB we've calculated from before, and AD we'll calculate a similar way, point D minus point A, which you get -2, -2, 0. So we take the cross product and we get 4, -4, 0, using the cross product formula that we've learned here. And now we can plug that into the normal form equation of a plane over here. So we end up with 4x minus 4y equals 4, which can be simplified to x minus y equals 1 if we divide both sides by 4. So now show that, as expected, C104 lies on that plane, so you plug in the corresponding x and y values and you end up with 1, which is the same as the equation, so that checks out. So now we're going to move on to part C and D. So find the length of the height of the parallelogram that goes from B to the edge AD. Use the height to find the area of the parallelogram ABCD. Then explain in your own words the advantages of the method used in part C for finding the area of a parallelogram compared to the cross product method. So here, since we're not using cross product, we will be using the formula of a parallelogram, which is area equals base times height, and we'll find the height using projection. So here in this parallelogram that I've labeled, this orange vector here is representing the projection of AB onto AD, and we'll find the vertical distance or the height by doing vector AB subtracted by this projected vector. So I'm going to calculate the projection of AB onto AD using the formula that we've learned in class, and remember, projection is essentially the shadow of one vector cast onto another vector. So after we plug into the projection formula, we get 2, 2, 0. So now, from there, to find the actual numerical value, we need to take the magnitude of that vector, which of AB minus projection of AB onto AD, which is 0, 0, 2. And remember, the magnitude is the square root of the sum of the squares of the components. So basically we have root 4, which is 2. And now the magnitude of the base, so we know AD from the previous parts of the question. So it's -2, -2, 0, and following the similar process from before, we get to root 2. As the magnitude of the base. So now plugging into the area of the parallelogram, base times height, we get 2 root 2 times 2, or 4 root 2. So why projection? Projection lets us isolate the perpendicular height component of a vector relative to a base. Without it, we can't calculate the true height in slanted 3D figures. So unlike the cross product, which gives area directly, this method keeps the geometry intuitive, as we can physically see the height and base at work. So this method is better because it kind of forces you to understand the geometry, makes the height explicitly visible, and really helps to solidify the concepts that we're learning and give a more intuitive and geometric interpretation of what it is that we're calculating and how to calculate the area. So That is it for question 4. I hope you understand how to solve it, and thank you so much for watching.